Consider quotient capital A times S plus capital B over quantity lowercase a s squared plus lowercase b s plus lowercase c, where the lowercase a times s squared plus lowercase b s plus c lowercase c is irreducible polynomial. How do we find Laplace inverse of this quotient? Before trying to do anything with this quotient, I suggest, even if the denominator is not irreducible, I suggest factoring the leading coefficient for the denominator out of the Laplace inverse. So for example, in this case, it's going to become 1 over a, because factoring a out is still going to be in the denominator, and Laplace inverse of capital A s plus capital B over s squared plus lowercase b over a times s plus lowercase c over a in the denominator. Now that we know about factoring out the leading coefficient of the denominator, let's try to find Laplace inverse of this format. Numerator capital AS plus capital D over denominator s squared plus bs plus c, and s squared plus bs plus c is irreducible. Now, the way to deal with this type of format is to remember two things. From your table, you have Laplace of cosine of kt is equal to s over s squared plus k squared, and Laplace of sine of kt is equal to k over s squared plus k squared. Now, if we do a shift, and let's say shift by L, here we will have Laplace of e to the power minus Ls cosine of kt is equal to the shift s plus L over s plus L to power 2 plus k squared. And the same thing here, Laplace e to the power minus Ls sine of kt is equal to k over s plus L to power 2 plus k squared. Because s squared plus bs plus c is irreducible, I know I can write it as a completed square. So let's do that. Let's complete this square for squared plus bs plus c, and that would be s plus half of this b, whatever, b could be positive or negative, by the way, to power 2. And then what extra thing that we created by raising this thing to power 2, let's remember that. Expanding this gives me s squared plus 2 times s times b half, which is b times s, plus b half to power 2. So let's subtract the b over 2 to power 2 and add this c. By the way, because this is irreducible, this entire thing adds up to a positive number. So that's a completing the square. That completing the square gives me the shift. So I know that my L in here is b half. What else do I need to know? Look at the numerators. I need to know if I can create s plus L and k in the numerators. It's more complicated to start with the sign value because creating s plus L is more complicated. You never start with the sine of kt. You always start with cosine of kt. So what I need to make sure that s plus L is created in the numerator over here. So how do I do that? Basically, I'm going to write this down as a, and L is b half, a times s plus b half. And then I figure out what I added to the numerator. So I want the numerator to be a multiple of this plus a multiple of that. And I start with the cosine of kt. So multiple of s plus L and multiple of k. And so this is as plus d is equal to this. Let's compute this again. It's going to be as plus capital A lowercase b half. And as is already here. I need to have this entire thing to add up to d. So what is left is going to be d minus a, capital A, b over 2. Now, this may not be k, so what do I need to do? I need to basically divide this by k, factor it out, and then have the k outside. How is this going to work? So I'm going to write it as a s plus b half over that completed square, which is c minus b squared over 4, then plus d minus ab over 2. And let's remind ourselves, what is k? K is that square root of this c minus b squared over 4. So that divided by that times this again over that. And so when you're doing a Laplace inverse, what's going to happen? I didn't write the entire denominator for the last one. What is going to happen is that you're going to have an a e to the power minus b half t cosine of the square root of c minus b squared over 4 times t plus this coefficient e to the power minus b half t sine of square root of c minus b squared over 4 close the square root times t. Okay, here's an example. Find the Laplace inverse of negative 5 over 18s minus 25 over 18, the entire thing over quantity, s squared plus 4s plus 13. How do we start this? First, complete the square so you know the shift. So completing the square gives me s squared plus 4s plus 13 is equal to s plus half of 4, which is 2, to power 2. Let's figure out what that is. It's s squared plus 2 times 2 times s, 4s plus 4. That is lacking 9. So I have to add 9 in here. So the two sides of the equations are the same. Now what do I know? From the, let's see, Laplace of square root of 9 is 3. This is a nice one. A lot of times it's not. But Laplace of cosine of 3t is equal to s over s squared plus 9. If I shift this by 2, Laplace of e to the power minus 2t cosine of 3t is equal to s plus 2 over s plus 2 to power 2 plus 9. And similarly, Laplace of e to the power minus 2 sine of 3t is going to be equal to 3 over s plus 2 to power 2 plus 9. At this point, I know that I'm supposed to write this numerator in terms of a constant times s plus 2 and another constant times 3. Let's start with, I know that because s is the only, it only shows up with the cosine shifted. I have to start with this, and the only time that s shows up in here is with negative 5 over 18. So let's write that out like that. Negative 5 over 18 times s plus 2. And let's figure out what extra things we are handling here. So this is going to be negative 5 over 18s minus 10 over 18. And then I will have negative, instead of negative 25 over 18, that's the constant we got. So I would say the leftover is negative 15 over 18 over the completed square. Now what do I do? Now let's factor out negative 5 over 18 times s plus 2 over s plus 2 to power 2 plus 9, which is this one. And then negative, I needed 3, so I'm going to write as negative 15 over 18 divided by 3 times 3. That would be negative 5 over 18 times 3 divided by s plus 2 to power 2 plus 9. And this one is e to the power minus 2t cosine of 3t times that coefficient, the Laplace inverse of that one. And the other one is 5/18 times e to the power minus 2t sine of 3t. So the Laplace inverse that we were looking for, Laplace inverse of the original, minus 5/18s minus 25/18 over s squared plus 4s plus 13. This Laplace inverse is equal to this value.